using all of the same like vocab and stuff that we used for pyramids. A cone is just a fancy pyramid with one base, obviously, because it's a pyramid, but that base is circular. So we have one circular base. I'm not going to spend too long on this vocab. Remember that when we talked about pyramids, we also introduced the idea of a slant height, which is different from our regular height. We are going to see both things, but our formula for pyramids and thusly cones will use this slant height as opposed to the regular perpendicular height, which we often refer to as an altitude. If it's a right cone, it might be called the axis, but we're going to focus on that slant height for sure. And then we also, because it's a cone, because it has a circular base, we're going to use radius quite often. And then if you take a look at those three things that I have highlighted here, the height, the slant height, and the radius, those are going to form nice right triangles for us that we can use like Pythagorean theorem, SOHCAHTOA, special right triangles, all that good stuff on to help us solve these cones. So that's our cone vocab. Let's go ahead and figure out our formula by drawing the net of this cone. So I'm going to take the circular base of my cone, and I'm going to draw that out first. The circular base has a radius r. And then I'm going to unfold that lateral area, and it does make a weird shape. You're just going to have to trust me on this. It makes a weird triangular, curvy triangle shape. I'm going to draw in this slant height here. And the slant height goes from the vertex down to the edge. I'm going to call that L. And then I need to describe what, I'm going to call it the base. It's not really a base because it's curved, but if that triangle were an actual triangle, we would call this the base of that triangle. How would I describe the length of this part? It wraps around the circle. So it's the perimeter of a circle. What's the perimeter of a circle called? The circumference. So we know that that part right here is our circumference, and it's represented by, this whole section right here is represented by 2 pi r. That's the circumference formula for a circle. Okay, good so far? So the surface area of this net is going to be in 2 parts. The surface area of this net is the area of that slanty, curvy looking triangle, plus the area of its base, which is a circle. We're going to have to use a little bit of imagination for that slanty triangle. We're going to imagine it's just a triangle. The triangle formula for area is 1/2 base times height. And then the area of a circle formula is obviously pi r squared. And then let's change those labels a little bit. So instead of 1/2 base times height, it's going to be 1/2. The base of this slanty, curvy triangle is the circumference formula, 2 pi r. And then the height of this curvy looking triangle is our L, our slant height, plus pi r squared. So the surface area formula for a cone, that 1/2 times 2 right there in the beginning, those are going to cancel each other out. So what I'm left with is the formula pi r L plus pi r squared. I really think this is one of the easier formulas from this unit. It's very straightforward. There's not a lot of extra stuff. You need the radius and you need the slant height, and it's just plugging stuff in. So I really like this formula. However, if you don't want to memorize this formula, that's totally fine. As long as you have the pyramid formula memorized, you should be good to go here, because this is, again, just a fancy pyramid. It's a fancy pyramid where instead of P for perimeter, we use the circumference formula. Instead of big B for our area of whatever base we have, we know that the base is a circle. We can use pi r squared. But again, fancy pyramid. Any questions on that so far? Okay. Here's our formula again, right here. Remember that this formula is represented by two different parts. It's the lateral area of that like curvy triangle, and then it's the area of the base pi r squared. So oftentimes we'll be asked for just the lateral area. Just remember that that's just the pi rl part. Okay, so with that in mind, I'm just going to start filling stuff in. I need two things for this formula. Slant height, which in this case, I'm already given the slant height, so that's awesome. And then the other part that I need is the radius. The radius in this case is half of my diameter. That radius is 8. So my formula is literally pi 8 times 9, our slant height, plus pi 8 squared. Why is my pen being weird? That's it. That's the whole formula. So I can simplify this. You guys know I like exact values, so I like keeping things in terms of pi. I would call this 72 pi plus 64 pi. We can combine these like terms. So 72 plus 64 is 136 pi. If you like exact values, you can feel free to leave it like 136 pi feet squared. If you really like decimals and you don't want to bother with all that nonsense, 427.3 feet squared is the decimal that I got. That's it. I think this formula is so nice and easy. Any questions on that? Okay, flip it over. Again, surface area formula. I'm going to write it up at the top. Pi rl plus pi r squared. Nice and easy here. So pi radius times slant height. I know the radius in this formula is 7. Do I know the slant height right now just looking at this diagram? No, it is not labeled for me. I want to be very, very careful here when I'm filling in this formula because they will try to trick you. That is not the same as height. Height is 24. Slant height is this guy right here. I have to do a little bit of Pythagorean theorem. 7 squared plus 24 squared equals equals slant height squared. If you know your Pythagorean triples really well, you probably already know that this simplifies to 25. If I can write 25. There we go. But that's a very super common mistake that I see is us trying to use the height instead of the slant height. The rest of the formula, pi radius squared. So this is, I believe, 7 times 25 is 175 pi plus 49 pi. In exact values, 224 pi. Or in approximate decimals, 703.7 inches squared. That's it. That's really it. Any questions on these cones? I'm going to breeze through a couple of them real fast. Number 3. I've got an ice cream cone. They are trying to package the ice cream cone, which means they're going to cover the entire cone with paper. We're given the diameter of the cone. We're given the slant height of the cone. I need to know the area of the paper that it's necessary to cover the cone. What's the most important thing about this word problem that I need to know when I'm setting up my formula? Is the entire cone going to get covered in paper? What part is not getting covered in paper? The base of the cone is not getting covered in paper. So instead of saying that my surface area here is pi rl plus pi r squared, I know that that pi r squared is not going to be part of my formula. So I can just find, hello, where did it go? I can just find pi r squared. Okay, apparently that just didn't. There we go. I can just find the pi rl part. So my radius here, if my diameter is 6, Then the radius is going to be 3. So this is pi 3 times my slant height, 15. 45 pi, aka 141.1 centimeters squared. Good? Any questions? All right. I do feel like composite figures are a little bit challenging still for a lot of us, not just one or two people, but I feel like a lot of us have been having the same questions. So let's talk about composite figures. I like to break these up into their different parts. I will find each surface area separately. At the end, I'll add them all together. I think sometimes on the homework and on the notes keys, like they get squished together all into one problem, which we can do, but maybe it's a little bit easier for us to see if we break them apart. So let's talk about the two shapes that I see. On the bottom, obviously, that's a cone. That's what we're talking about today. On the top, it's got two bases. That's a cylinder. So I'm going to split this into two parts. I'm going to find the surface area of the top part, which is the surface area of a cylinder formula. I need to know about that cylinder, though, what parts are visible from the outside. And I already highlighted that part in the center there. That's on the inside of that shape. That's not going to show from the outside, which means I don't want to include it in my calculation. So if I'm talking surface area of a cylinder formula, I don't want both bases. The base on the top is visible, but the base on the bottom is not. So I'm going to say the surface area of the cylinder with only one base. If I look on my notes or over there on the board over there, number 12, that's my cylinder formula. It is 2 pi r times h plus 2 pi r squared. If I only want one base, though, I'm going to multiply it, or I'm not going to multiply it by 2, because I only want one of those circles. Does that make sense? Okay. All right, so then let's plug some stuff in. The radius of that cylinder is 6. The height of that cylinder is 3. So this is 2 pi times 3 times 6 times 3. Plus, I'm not going to multiply it by 2 because I only want one base, just pi radius squared. Now I can do my exact values. I'm actually going to leave this in exact values. I'm not going to round it because then I'm going to add them all together at the end. I'm going to leave this as 72 pi for right now. That's the whole top part. Now the surface area of the bottom, I'm also going to do separately. I know it's a cone. What do I need to know about that cone? How much of that cone can I see? Or what parts don't I see from the outside? Anna? We don't need the base of it. So it's the surface area of the cone, no base. So again, let's do our cone formula. Pi r L plus pi r squared. The base part of that cone is the circle. It's pi r squared. So I'm not going to include that whole part. Let's see. Radius of my cone is 6. The height of my cone is 7. But what do I actually need? I need the radius and the slant height. So if I only have the radius and the height, I got to do a little bit extra work here to find my slant height, which I'm going to call L. It's nice and easy. I'm just going to use a little Pythagorean theorem here. 6 squared plus 7 squared equals L squared. If you're anything like me, I really, really like keeping things in exact values. So I'm going to find that this is 85 equals L squared, or that L is the square root of 85. And then rather than make that a 9.2 and like having to round that number, I'm just going to leave it as the square root of 85 because I'm about to put it in my calculator anyways. It doesn't really matter if you keep it as an exact value in terms of radicals, or if you, what's it called? If you round that number, I'm okay with either. I just like it to look a little bit pretty here. So in exact values, this is like 6 pi times the square root of 85. And then I know that I need to put both of these numbers together in my calculator, and I'm running out of room, so maybe I'll squish it in over here. The surface area in total, 72 pi plus 6 pi square root of 85 equals, as a decimal, 399.97. If you wanted to round this to 400 feet squared, that would be fine. Okay. Any questions on that? I feel like I know these composite figures are hard. You just have to take it piece by piece and think about what parts can you see and what parts can't you see. Good? Last one, I love these problems. We've got a cone that has a lateral area of 180 pi, so we're starting with the final area. And then I need to know, or I know the slant height, I need to find the radius and then the surface area. So it says a cone has a lateral area 180 pi. What in my cone formula is the lateral area? The whole thing is not the lateral area. The lateral area is just the sides, Caitlin. Perfect. In my formula, I have pi RL plus pi r squared. The pi r squared part, that's the base. Pi r times slant height is the lateral area. And I know that that equals 180 pi. So this is the lateral area. I know it equals 180 pi. And I know the slant height, but I don't know the radius. So I'm going to set up my formula. 180 pi equals pi times the radius times the slant height, 15. I'm going to divide everything by 15 pi, which cancels out those pi's. And 180 divided by 15 is 12. So there's my radius right there. Good on the first part? Then I know that surface area, if we think about what surface area is the lateral area of the sides. For a cone, it's plus one of the bases. So to find the surface area here, I will take the lateral area that I already know. That lateral area is 180 pi. And then I will add on the area of the base, which is pi, my new radius that I just found, squared. (180) plus 144 is 324 pi centimeters squared, or as a decimal, 1017.9. Any questions? Yes.
Tess, do you want us to just leave it as pi if we're good with that, or do you want to
I am totally fine with you leaving it in pi. I have all of my answers in terms of pi, and I also have all of my answers rounded to the nearest, I think I did 10th place. Yeah, 10th place it looks like. So I will take either one.